Welcome back. We're going to continue our look at two variable linear systems of equations by checking out the next method, which is substitution. Solving by substitution means we're going to take and isolate a single variable. Doesn't matter. Certainly there are some that are easier than others, though. And we're going to replace it in the other equation. So if we solve for x, maybe in this equation, we'll plug whatever it equals to back into this other x. This method is most easily used when there is a coefficient equal to 1. To isolate that variable is going to be easiest. It's just the way it is. It certainly works with other variables, but the substitution isn't as complicated when we have one of the coefficients equal to 1. For example, solve the following systems of equations by substitution. Even though we don't have any of these set equal to 1, we've got one that's really close, -1. So what I'm going to do is solve for x in this case in this equation. I'm going to take x to the other side. 5y equals 17 plus x. Subtract 17. 5y minus 17 equals x. At this point, since x and 5y minus 17, they're the same thing. That's what it means to be equal. Anywhere I see an x, I'm going to replace that with 5y minus 17. So in our other system, we're going to say 2 times 5y minus 17 plus 3y equals 5. This means that 10y minus 34 plus 3y will equal 5. So 13y will equal 39, and y equals 3. We need a solution. We need two numbers. So once we have this, we're going to use substitution once again to plug that back into my y to come up with the solution. So 5y minus 17 equals x, which means 5 times 3 minus 17 equals x. That becomes 15 minus 17 equals x, which means x equals -2. So our solution is -2, 3. I don't know why this is happening, that all my solutions are combinations of 3's and 2's, one of them being negative. I really am not intending this, but it's humorous nonetheless.